Thanks everyone for attending this research talk. My name is Muhammad Naisa, University of Southampton, Trustworthy Autonomous Systems Hub. Today I will speak about explainable recommendations when design meets trust calibration. And it's a paper published in the www journal. So for further information, you can look at the paper. And the goal of this research is to understand how we can enhance the role of explanations in enhancing the trust calibration. I will start by introducing the research context and the research problem. Then I will present the research question, our method, discuss the results, and present some future work. So calibrated trust, what does it mean for human AI interaction? So calibrated trust is the successful judgment of the actual AI capabilities and limitations. And people working with the AI shall be able to judge when to follow correct recommendations or when to reject incorrect recommendations. And this has been an essential goal in the literature for designing safe and responsible AI tools, and especially when the AI and the humans are working together. And this has been the interest of the research due to the increasing adoption of these tools in critical domains such as healthcare or defense. These challenges have motivated the scholars and researchers in explainable AI to develop explainable algorithms and explainable models to generate explanations from AI. And this was to increase the transparency and explainability of AI models. So the role of explanation in trust calibration is to help people to understand the rationale behind each AI recommendation. So people in this context can judge whether to follow the AI recommendation or to reject it. However, researchers always assumed that people will engage cognitively and make effort to understand this explanation. And this has been shown in recent empirical studies that explainability failed in many situations to promote a successful trust calibration. People using the AI still end up in a situation when they follow incorrect recommendation or reject correct ones. So many research actually found that people still do not form correct mental model even when explanations are communicated to them. This motivated us to conduct this research and provide these assumptions about the role of UX or the interface design in enhancing the role of XAI in trust calibration. So we defined as UX for XAI in such context that the system shall ensure conveying the explanation without requiring high cognitive task and it introducing minimum interruption to the human AI task. For example, this distraction in the UX design is something to avoid when designing interfaces. However, it could be possible for XAI design because sometimes we need to nudge people to look at the explanation and prevent any human biases. So we put this research question, how to design for explainability that enhances trust calibration. So we conducted a multi-stage qualitative study. We first chose a case study to explore the research question. We chose an AI-based screening prescription tool, and this AI screening prescription tool is a process that medical practitioners follow in the clinic to ensure that the prescription is prescribed to fit the patient profile and do not have any further consequences on the patient based on the patient history and stuff like that. So we choose this case study as it reflects an everyday human AI task. So people making many decisions with the AI every day. And that was essential for this research to understand where explanations could fit in this task, and also to understand if there are any trust calibration errors happening during this interaction and why these errors could happen. So we wanted to explore these patterns of behavior of the users while working with XAI interface. Then also we looked at the explainable AI literature. So we wanted to know what can we explain to users when we have a black box model. Okay, so we focused on a family of algorithms that can interpret any machine learning algorithm. So in this case, we found 4 explainable AI classes, which is counterfactual explanation, local feature importance explanations, example-based explanations, and global feature importance explanations. So each of these explainable models could be applied to any machine learning model. So it was useful to our case study, and also because these XAI tools are usually used in the XAI literature in a way it's designed for data scientists and machine learning experts. So we wanted to know also how people working with the AI could interpret and understand these explanations and implement them in their human AI task. So our method consisted of 2 phases. The first phase is about think-aloud protocol with 16 medical practitioners who previously used our AI-based tool, which is the screening prescription. So we asked our participants to use our developed AI-based tool and make decisions with AI. We encouraged them to think aloud and express their understanding to the AI and what they think about the each explanations. And also during our let's say the study settings, we included incorrect and correct recommendations to our participants to see whether the explanation itself is helping our participants to identify correct or incorrect recommendations. So, for example, and we choose these settings actually to reflect what could happen in real-world scenarios when the AI could err and the AI could have some dynamic nature and uncertainty in its decision making. So each participant completed 10 different human AI tasks. This phase results actually help us to understand why explanation were not always helping people in their trust calibration process. So why people make mistake if they did, why did they make these mistakes, any interesting patterns. So we were interested more about how people use the explanations in their decision-making task and also how they interpret these explanations also. In phase 2, after analyzing the data from phase 1 and came up with some user behavior patterns, users error, we invited medical practitioners, UX designers, and researchers to form some concepts and design principles, how we can mitigate these errors and how we can enhance the role of explanation during a human AI task. So the results from first one came up with some usage pattern, as I mentioned before. So 46% of participants' tasks were successful and they used the explanation properly. However, we found 30% of participants' interaction style were skipping. So participants just skipped the explanation. They didn't use it in their decision-making task, and they made some errors because of that. And also, we found that participants also misapplied the explanation in their task. So, for example, participant rush understand the AI capabilities and limitations from the beginning of the study. So we found people at the beginning of the study, they read the explanation, they formed some mental model, and it wasn't correct. So at the further interaction, they did not read the explanation because they already formed some mental model from the beginning of the study. So they formed an incorrect mental model. Also, we found also some participants misinterpret the explanation in their task. They didn't really know how to use this explanation because, yeah, as I mentioned before, some of these explanations were meant, for example, local feature importance were mostly meant for data scientists to debug this model. So sometimes it was hard for people to correctly interpret these explanations. We also found that people lacked the curiosity also to look at the explanation. They thought that the explanation will not add any new knowledge to them. So they were more skeptical to use it. Then after coming up with all these errors and this user behavior, we invited researchers and UX designers and also medical practitioners to design or to introduce some UX principles to mitigate these errors and enhance the role of explanations in trust calibration. So the first principle that we, together with the participant, came up with is the engagement principle. So participant thought that increasing user tendency to engage with the explanation could engage participants to or users to read the explanation and put more effort while working with the AI. So, for example, they suggested as healthy cues as a way to motivate participants to work with the explanation. And the healthy cues is just showing the participants some information about what other people doing with this explanation. So they wrote a message next to the explanation. Several medical practitioners use this explanation to validate the AI output. So it's more like engagement and persuasive design to encourage people to use the explanation and form some kind of correct mental model. The second principle is about slowing users' actions while working with the explainable AI. So instead of making rush decisions while working with the AI, participants suggested some kind of friction principles that slow users' actions in a way that help them to reflect on their own action. So, for example, they suggested and design techniques where when users spend less time than expecting while working with the AI. So, for example, if the users spend, let's say, 10 seconds while looking at the recommendation and the explanation, there will have some pop-up message that slow down this action and help users reflect on their actions. The other principle is challenging user habitual actions or preventing any habitual actions while working with AI. And this could reduce their capability to or increase their capability to utilize the explanation and help trust calibration. For example, they introduced what they called a downstream approach. It's about providing users with some material to introduce the benefits of the explanation in their task, so they are more aware about the benefit of the explanation. They also introduced some other approach, which they call upstream approach, which they change the structure of the interface. So, for example, before introducing the AI decision, the explanation could be introduced. So, putting the explanation before the AI recommendation. So, it's increasing or challenging any habitual action when accepting the AI recommendation directly. Another principle, it's about guiding the attention of user, so helping user to move from one element in the interface to another element. So, for example, using some kind of colors, navigational arrows, and stuff like that. So it's about guiding user in the interface and providing them with some navigational or attention guidance principle to look at different positions in the interface. The other one is an education principle, which help participants to interpret this explanation. So, for example, participant added some kind of a button that show users how to actually interpret and use this explanation. It's more about training the users about using some kind of explanation if the explanation wasn't really understandable or meaningful to them. So it's about explaining the explanation itself. So yeah, we look in the future about more experimental studies to validate these principles and to see how people will use these principles and how these principles will actually help trust calibration. And also in the future, we look about linking between some user errors that we already identified in the first phase and linking them to some design principles. So also we're looking more about experimental studies to make that mapping between users errors and design principles. Thank you so much for listening to this talk. For any question, please contact me on this email